So for this week, you're going to get some practice now on solving some systems of equations. I'm not concerned necessarily with which method you used. Just keep in mind that whenever I do go through the answer, I may use a method that you did not use, or I may have gone a different route using the same method that you chose to use. Just keep that in mind. And kind of see what I do, and then make sure you go back and use that as an idea to possibly find any errors you may have made. Of course, if you find any errors and you still can't decide what they were based off of looking at my review of the problem, then by all means make sure to get in touch with me. But here we go. So for this system of equations, it's already kind of set up to do the elimination. And when I look at this, I always look for the easiest way to do elimination if I can. I mean, it doesn't matter which variable you choose to eliminate, but you could choose to eliminate the x's or the y's. But I can see that the y's, 2, is a factor of 6. And they already have opposite signs. So if I just simply, choose to eliminate the y's and multiply the top equation by 3 on both sides, I'm going to get the same number in front of the y with different signs, and therefore when I add the two equations together, the y's will eliminate. So that's the route I chose to go. That's not the only way you could have done it necessarily, but keep that in mind. Sometimes if you look into it maybe a few extra seconds, you could probably find an easier way depending on the circumstance. So the top equation does become 9x plus 6y equaling -3. The bottom equation was untouched, and so now when I add these together, the 6y's cancel. I end up with 16x equaling a -48. Dividing both sides by 16, I get that x equals -3. Now that I know that x is -3, I can choose one of the two original equations. I just happen to choose the bottom one, replacing the x with -3. And I'm going to solve this one for y. So -21 minus 6y equals -45. I add 21 to both sides. And get that -6y equals a -24. I'm going to divide both sides by -6. I get that y equals 4. So the solution is the ordered pair -3, 4. Let's move on to the next one. For this one, because this bottom equation is already solved for y, this is one of the cases where it actually is set up to do substitution, somewhat regularly, because I already have one of the equations solved for one of the variables. That's not to say that if they're both written in a form that that you're going to see me more often than not choose to do elimination. If you prefer substitution, you're more than welcome to solve the equation for whatever variable that you want to solve for and go from there. So just because I'm choosing to use substitution does not mean that's the correct method. It's just one of the correct methods I can use. So since I'm using the bottom equation to define my substitution, I'm going to go to the top equation and replace the y with 4x minus 9, because we know that y equals that. I'm going to simplify the left hand side by distributing that -3. Make sure you do distribute the -3, which means that -3 times -9 becomes a +27. Combining some like terms, I get -7x plus 27 equaling 13. Subtracting 27 from both sides, I get that -7x equals a -14. And then dividing by -7 on both sides, I do get that x equals 2. Now, with knowing what x is, I can substitute the 2 in for x in either one of the two equations, but since the bottom equation was already solved for y, me just plugging in the x is going to give me y immediately. I don't have to do any manipulation. It's just going to be more of a plug and chug. So y equals 4 times 2 minus 9, which is 8 minus 9, which is -1. So y equals -1, which makes the solution the ordered pair to -1. On to the next one. And aside from the errant mark here, which is just part of an explanation that you'll hopefully see as we move along with this, it'll appear. This top equation here is mostly solved for x. And sometimes, if you look carefully enough, I see a 3x and I see a 9x, which means that this is just a multiple of 3x. So I'm going to use that to my advantage here, because if I use that to my advantage, then I can realize that, this bottom equation is basically 3 times 3x minus 5y equaling 7, and therefore I could just replace what's inside the parentheses now with the 2y plus 7, or plus 1, sorry. I mean, of course, I could always divide both sides of this top equation by 3. I would get some fractions involved, which sometimes turns some students off of that. But sometimes if you notice things like that, you could take advantage of it and make it just a little easier to handle. Distributing the 3, I get 6y plus 3 minus 5y equaling 7, which gives me that y plus 3 equals 7. Subtracting 3 from both sides, I get that y equals 4. And now that I know that y equals 4, I'm going to go back and use substitution. I'm going to use the top equation again and just replace the y with the 4. So 3x equals 2 times 4 plus 1, which means that 3x equals 9. And dividing 3 from both sides, x equals 3. So my solution is the ordered pair 3, 4. Try the next one. So for this one here, I'm going to choose to do elimination because it's already kind of set up for that. Although it's, kind of like the first one we did, 2 is a factor of 6. I already have opposite signs. This would work kind of nicely if I chose to eliminate y's. It's even easier if I choose to eliminate x's because I already have the same number in front. All I really need is one of these to have the opposite sign. So I'm going to choose to eliminate x's on this one. And I'm going to multiply the bottom equation by -1 on both sides to get a -5x here. You could have chosen to go a different way. That's fine. Just make sure that whatever variable you're looking to eliminate, you're getting the same coefficient in front of it, but having an opposite sign. So the system of equations becomes 5x plus 2y equaling -39, which is the top equation just rewritten. The bottom equation becomes -5x plus 6y equaling 23. When I add the two equations together, the x's do cancel. I'm left with 8y equaling a -16. Dividing both sides by 8, I get that y equals -2. I then go back to one of the original equations. In this case, I did choose the top equation. I replace the y with a -2. So I have 5x minus 4 equaling a -39. I add 4 to both sides, and I get that 5x equals a -35. At which point, when I divide both sides by 5, x would be a -7. So my solution is the ordered pair -7, -2. On to the next one. Now for this one here, again, it's already set up to do elimination. I usually only do substitution if I have a situation where one of the variables is either isolated completely or almost isolated. You could use substitution, but you would have to solve one of these equations for one of the variables. Which case, you're going to probably deal with fractions in most of the cases if you try that. When I look at, as far as elimination goes, which variable I would choose to eliminate, I could eliminate x's, but 3 and 5, they're not factors of each other, so I would have to find a common multiple of the two. 15 would probably be the smallest one, and so both equations would have to be manipulated. Whereas I look at the y's, 4 is a factor of 8, and I already have opposite signs here, so if I were to multiply this by 2, I would have the situation where when I add the equations together, eventually the y's would cancel. So I am just going to multiply the top equation on both sides by 2 to eliminate the y's. And so the top equation becomes 6x minus 8y equals 12. The bottom equation was left untouched. And so when I add these two together, I get that 11x equals 33. Dividing both sides by 11, I get that x equals 3. And now I go back to one of the original equations. I chose the bottom one in this case and replace the x with 3. So I have 5 times 3 plus 8y equaling 21, which means that 15 plus 8y equals 21. When I subtract 15 from both sides, I get that 8y equals 6. And dividing both sides by 8 gives me 6 divided by 8, which does simplify into 3/4. So you can get fractions or decimals on these. It's not unheard of, so just be aware of the fact that you could possibly get those sort of situations on this as well. And on to the last one that you're going to be asked to do for practice. So for this one, I'm actually going to do something that's not required to do, but I'm going to do it because just to show you that there's methods of handling things that sometimes make students feel uncomfortable. One of the things that makes students feel uncomfortable when you look at the top equation, obviously there's some fractions involved there. Decimals don't usually cause as much trouble for some students, but when they see fractions, sometimes they just like kind of freeze. And if you have fractions involved with an equation, you can at least temporarily get rid of them. That's not to say that you won't have fractions reappear at some point, that any answers may not be fractions, but you can certainly find a way of getting rid of the fractions at least temporarily, especially in situations like this when you're looking for common factors and things like that if you're choosing to use elimination. So for this one here, when I look at the top equation, I do have a denominator of 4 and a denominator of 3. 4 and 3 are both factors of 12, which means if I would multiply this entire equation, both sides, by 12, I would get an equivalent form, but I wouldn't. But the fractions would eventually would essentially go away. So if I multiply the top by 12 to get rid of the fractions, it's adding a step to it, but it certainly makes it sometimes in some students' eyes a little bit easier to handle. So the top equation would become 9x plus 8y equals 120. The bottom equation, I haven't done anything to it yet, is going to remain that. Now, it's, the bottom equation, it's kind of set up that, that I could do elimination with either variable, because it isn't too hard to turn a 1x into a 9x, or a y into an 8y. It's also not very difficult for you to, solve the equation for either x or y, and be able to do a substitution. So I mean, you could go many different ways with this one, and all of them would be fairly easy. I mean, there wouldn't be one that I would say is easiest of all. But I chose because of the fact that I have this already set up for an elimination look to it. I don't already have an equation solved for a variable. I see that these already have opposite signs, so I don't have to worry about multiplying by negatives and making sure I'm sign changing everything that needs a sign change. If I just multiply the bottom equation by 8, that would eliminate the y's when I eventually add them together, because I'm going to have top equation stay the same. The bottom equation is going to become 8x minus 8y equals 16. So now when I add the equations together, the y's do cancel. I'm left with 17x equaling 136. When I divide both sides by 17, I do get that x equals 8. And so, I know what the x is. I go back to one of the original equations. In this case, I happen to choose the bottom one. And I get that 8 minus y equals 2, which, I can show the manipulation, but this is one of those basic equations where most students can figure out, well, 8 minus what equals 2? Well, y has to be 6. So the solution is 8, 6. And that brings me to the end of the last question that you have to do for practice. If you have any further questions, please reach out to me and ask about them. Until next time, have a good day.